You know, it's well documented. There are 10 different kinds of people. Those that understand binary and those that don't. I'm Mr. McBrien. This is TEJ2O, the binary number system. The Ontario curriculum states that students will demonstrate an understanding of the use of binary numbers, hex, and Boolean. Today we're going to focus on binary numbers. So, binary numbers are often very challenging for students, not for any really good reason, except that we've spent so much time on the concept of our decimal system, our normal number system, that it seems like those are real numbers and anything else is something foreign. So our base 10 system, really in place probably just because Neanderthals had 10 fingers, uses 10 digits, 10 shapes that we use to represent the numbers from 0 to 9. And that's it. We have those 10 shapes. And of course, as soon as we move past those 10 shapes, we have to start carrying digits. And that's what we spent the first couple of years in mathematics learning to understand. If we analyze a little deeper, if we dig a bit deeper into the decimal number system, then we get this idea of each digit representing a number that is a multiplier times 10 to the exponent of 0, 1, 2, etc. So we can analyze the number 257, what we call 257 in base 10. And we can say it's 7 times 10 to the 0, 5 times 10 to the 1, plus 2 times 10 to the 2. And then we can just simply do the mathematics. 200 plus 50 plus 7 gives us our number 257. And this is very natural to us and almost seems foreign to talk about it in these terms. But if we truly understand this table, then we can understand numbers in any number system, any base. So we can have base 2, 7, whatever we want, or even 16, as we'll see tomorrow. Today we're going to focus on the binary number system. Bi meaning 2, and of course it uses a base of 2. It means there are only 2 digits we can use, a 1 and a 0. And of course the reason why this system is necessary is because the little switches that we have inside computers, transistors, only have 2 options, on or off. And those 2 options dictate that it uses a number system very different from our own. So, I mentioned that table system, we can use it for any number system. Well, here's a table for the binary number system. Instead of 10 to the 0, we have 2 to the 0, but these are still 1s. However, the next column over is 2 to the 1, or 2s. Next over, 2 to the 2, or 4s, 2 to the 3, or 8s, 2 to the 4, or 16s. And this table dictates what our binary numbers represent. So in a case where we have the binary number 1, 0, 1, 1, it's 1 times 2 to the 0, or 1 times 1, plus 1 times 2 to the 1, or 1 times 2 equals 2, plus 0 times 2 to the 2, or 0, plus 1 times 2 to the 3, or 8. 1 times 8 equals 8. And this is our number 1011. If we want to convert it back to decimal, then What we have to do is take those numbers and put them into decimal form and then add them together. So 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1 is 8 plus 0 plus 2 plus 1, or 11. So the number 1011 in binary is equal to 11 in decimal. And so we can do these conversions. We can do those conversions every time using our table. And I'd encourage you on the test to do that. Draw the table and use that table each time you do the conversions. So you draw the table, write in whatever binary number the teacher gives you, and then simply do the mathematics from there. Do multiplication. So we can ignore all the zeros because 0 times anything is 0. And we can say, okay, 101101 is the same as 1 times 32 equals 32 plus 0 times 16 plus 1 times 8 is 8 plus 1 times 4 is 4 plus 0 plus 1 times 1. 32 plus 8 plus 4 plus 1 equals, if my math is right, 45. Any conversion from binary to decimal is just that simple. It's a simple matter of multiplication and addition. So if we try another one, the binary number 100110, we can do that one as well. I'd encourage you to consider pausing the movie right now and do it on your own. But if you don't want to, that's fine. You can go ahead and work through the worksheet and come back. Now, let's talk about converting from decimal to binary. It's not quite as simple. And the reason is that we have to do subtraction instead of doing addition. But we can use the same table. And this, as long as we successfully draw this table, is really a fairly trivial process. So let's take an example of 15. What we can do is we can say for 15, obviously 128, 64, 32, they're much bigger than 15. We have zeros in all of these cases. And some quick thought, 16 is bigger than 15 as well. So we need 0 16s to represent 15. Then we get down to 8, and 8 is smaller than 15. We need one of these to help represent 15. Now when we do this, we need to say to ourselves, okay, how much of 15 is not represented by that 8? And so the way we do this is with subtraction. So we subtract 15 minus 8 means 7 is still unrepresented by that 1 in the 8's column. So our new problem is just, how do we represent 7 in binary? Well, 7 is bigger than 4, so we're going to need a 4 to represent it, so we can put a 1 in. And then we do the same thing. We say, okay, how much of 7 is not represented by a 1 in the 4's column? And the answer is 7 minus 4 is 3. By the same process, we can say we need a 2, subtract 2 from 3, and we get 1. We need a 1. When we're finished, 8 plus 4 plus 2 plus 1 is 15. Or 15 in binary form is 1111. So if we try another one, we can convert the decimal number 75 to binary. And if we were in the classroom, I'd probably do this on the board. But since we're not, you can go ahead and do this one on your own. Pause it and come back. And also, if you wish, you can work through some of the numbers on the worksheet. All right. Now let's talk about addition. When we consider addition of decimal numbers, we've done it so much that we really don't think about it very much anymore. It's pretty straightforward. But the key thing to understand is that anytime we reach a number higher than the highest number we can represent in that column, we have to carry. And we do this pretty casually now. So when we go to add 16 plus 25, we first consider the numbers in the ones column, and we say 6 plus 5 is 11. We say, well, wait a second, 11 is too big to represent in the ones column. So we subtract 1 0, or 10, from that number, write a 1 in, and carry the 1 0 to the next column. And then we can add those together. And in this case, we get a 4. And of course, this is small enough, we can just write the 4 in. So we do it considering one digit at a time. In fact, we can do the same thing in binary form. So when we go to add binary, we, using the same logic, carry a digit whenever we get to a number 2. So let's try an example. 1011 plus 11. When we add 1 and 1 together, of course, we get 2, and we can't represent a 2 in this column. So what we have to do, we have to carry a 1, of course. We have to carry a 1, of course. So we carry the 1 to here, and we write in a 0. 1 plus 1 in binary is 1, 0. So we write the 1 up here, write the 0 here. And then we have 1 plus 0 plus 1. Or again, 2. We write in a second 0 and carry the 1 once again. Again, 1 plus 1 is 2. We write in a 0 and carry the 1. So 1011, 101 plus 11 is equal to 1, 0, 0, 0, 0, 0, 0. Yes. Okay. We can use similar techniques to that in subtraction, multiplication, division, but we're not going to bother in TEJ2O. So what I'd like you to do, I'd like you to go through the binary workbook tonight and fill in all the answers, conversion to and from binary, as well as addition of binary numbers. Tomorrow we'll start on hexadecimal numbers. Thank you, and have a good day.